When we talk about convergence in a network, we want to address bidirectional forwarding detection, or BFD. Now, this is a feature that is used to detect the liveliness of a link. In other words, it looks to see if we have two-way data, bidirectional data on the link. It doesn't help us figure out what we should do if we don't have bidirectional data, but it does help us determine if we're only seeing traffic in one direction. Now, this is a protocol that can be used at any layer as far as protocol use goes, but it's usually seen when we talk about our routing protocols for EIGRP, OSPF, ISIS, and of course BGP. So the way that this works is we end up having one BFD session per client protocol. So one BFD session for EIGRP, one BFD session for OSPF, and so on. If a device doesn't receive a BFD control packet, what happens is it tells its client protocol, so in this case it would be EIGRP, that it now sees a failure. Now, these BFD control packets, are sent via UDP. They use port 3784, and what happens is EIGRP tells BFD of the IP address of a neighbor. So BFD doesn't know who it's supposed to be sending these UDP packets to. It learns them via EIGRP. So EIGRP tells them here is the peer, and then the client protocol figures out what the appropriate response would be. So the routing protocol peering session termination, for example, would be handled. This would all be handled by the routing protocol itself. BFD really doesn't get involved in this. It just simply replies back and says, hey, we've had a failure here. So BFD creates a control packet. These packets get sent at 1 second intervals, and that happens until the BFD session establishes. Then the remote router gets a BFD control packet. It does this during the session initiation phase. It copies the value of the my discriminator field into its own your discriminator field, and then sets the I hear you bit, or the H bit, for any subsequent BFD control packets that it then transmits. So once both systems see their own discriminators in the response packets, now we know that we're talking and we're good to go as far as that BFD session goes. The session is established. Now, there's timers that go along with the BFD session. They're established when we negotiate, and these timers can be 50 millisecond intervals in one direction, and then the other peer could be sending every 200 milliseconds in the other direction. As long as that is negotiated up front, they're okay. And as long as each BFD peer gets a BFD control packet within the detect timer period that they negotiated, then that session stays up for whatever routing protocol BFD is working for, and BFD maintains its adjacencies. So if a peer doesn't get a control packet within that interval, it's going to tell the routing protocol that there's a BFD session failure, and then the routing protocol would then determine what the response should be. So maybe it's the routing protocol's peer session termination that's going to happen here. And that would be the typical response that would happen. If BFD says we can't talk, then the neighbor relationship, that peering, would go down.